Hey everyone, thanks for joining us for the last episode of our Learn Live Security 101 series, SecOps and AppSec Fundamentals. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our speaker for today. Sarah, thank you so much for joining us.
Hello, thank you for having me and welcome back everybody. So this is our rescheduled and therefore now the last episode of Security 101. So thank you for joining me today. So today we're going to talk about SecOps and AppSec fundamentals, and then we will have rounded off our whole Security 101. Again, little bit not as short as yesterday, a little bit shorter than some of the other episodes, so we probably won't go the whole time we've got, but let's see how we get on anyway. As usual, please ask questions in the comments. Yesterday I actually had the wrong tab open, so I didn't see the questions until after we finished, so my apologies. So this time I do have the right tab open and we'll actually look at the questions if you have any. So what we're going to cover today is we're going to look at security operations, what the key concepts are around security operations, what is it? We'll look at how we do zero trust architecture for our security operations. Then we'll look at some of the capabilities and the types of tools that you should be using to support your security operations. Then for application security, we're going to look at that. We're going to look at the key concepts and some of the tooling that you can use to secure applications. We'll also then round off with a Q&A and any other last questions as well. And I'll also talk a little bit about if you want to continue doing some security learning, where you should go from here. So, of course, as you know, say hi. We're live. I am doing this live from Melbourne in Australia. So say hi and ask questions. As I said, I am looking at the correct tab today, so I should actually be able to answer them as we go. But let's crack on and get on into it. So let's look at security operations and what security operations is. So security operations, or SecOps, as some folks may know it, is either a team or a department that are responsible for monitoring all the systems in an organization. Now, some security operations is traditionally quite an expensive business capability to run. And so it tends to be only larger organizations that have their own security operations function. Other organizations may outsource it to like an outsourcer, a third party, because setting up a whole security operations center and having your own security operations analysts and people who are looking at things is generally quite a big outlay. So small and medium businesses may not do it. And also it might be that it might not be a whole team doing it. It might just be one person. Equally, on the other side of the fence, the security operations might be multiple teams. It might be multiple teams rather than just one. So it really does depend on the size of the business, the scope, and other things. And the main goal of security operations, of course, is to, in the moment, check that security is being maintained. And if we go back to the CIA triad, it's the confidentiality, integrity, and availability of an organization's assets are being maintained so the business can run. And if there is a security incident, they will respond to it effectively. And as other operational things go, they will be, their idea is to if there is an incident, just like in general IT operations, they'll be trying to isolate it and minimize that impact as soon as something is actually identified. So as I said, there can be different roles within security operations, depends on the size of the organization. But here are some common forms that security operations can take. Probably the one that's most widespread is your security operations center. We just call it a SOC. So a SOC is where you often have analysts who will be looking at tooling, understanding what's happening in your environment, and if they need to respond, they will. In larger organizations, they might also have a separate incident response team. Here in Microsoft, we have incident response teams who specifically go and actually respond to incidents rather than our monitoring teams. We also actually have an incident response team that customers can use as well, who they will go in, they will identify what the problem is, they will isolate it, they will clean out the attackers, bad people, and then you can take some remedial actions, and then they'll go back to doing what they should be doing before. And I don't know why I'm yawning again. Threat hunting is more the proactive things, looking for threats. It might be particular types of threat actors. And then we have red team and blue team. So red team are penetration testers and blue team is the defenders. That can also be something that comes into security operations. And then finally, we've got the managed security services provider, or the MSSP. So as I was saying before, a small organization might choose to out a smaller organization, or even a bigger one if it doesn't make sense for them. We may like outsource their security operations to a third party. And you'll see in lots of tooling that, and we have this in Microsoft as well, that the tooling allows for like a third party to manage it as well. So I guess one of the things to talk about here is, how does security operations differ from traditional IT operations? So there is a lot of overlap, no doubt, but of course, security operations has a different focus. IT operations generally focuses on managing and maintaining an organization's IT infrastructure, and maintaining that functionality and availability, whereas security operations will more prioritize, although availability is important, they will prioritize identifying security risks and responding to those incidents. And IT operations, they generally, in terms of responsibility, they'll be looking at system maintenance, software updates. They'll be looking at user support, things like that. Whereas security operations are looking at threat detection. They'll be looking at vulnerability management, which we've talked about, and that security monitoring. And then in terms of the timeliness, IT operations will always emphasize availability and immediate availability and performance. Whereas security operations is concerned with availability, because of course if stuff isn't available and doesn't work, but they will probably prioritize fixing a security incident. So occasionally, if there is a security breach in an organization, security operations might have to shut down something in order to remediate it and fix it and isolate the problem, which of course isn't what IT operations would like. But sometimes, unfortunately, in severe cases, that can be necessary. Then the skill set is obviously quite different as well. IT operations is more system admin, network management, application support, whereas SecOps people tend to specialize in threat analysis, security incident response, and of course, the tooling, which we're going to talk about shortly as well. So it is quite a different skill set between, although there's elements that overlap, they are separate, certainly in terms of what they want to achieve, their goal, and the skill set that you need. Now, here we've got the incident response workflow. Now, we've actually looked at this already, but I just wanted to remind you of it. This is our cybersecurity incident response workflow. So, and as you can see, it's in a circle because this is a continuous thing that will happen. So it's identify, then protect, detect, respond, recover. And we go round and round and round in a circle because this is not a one-time thing. And of course, security operations teams use this as well because they will want to be monitoring. They'll identify a threat. They'll identify a threat. They'll put in detections, which I'll talk about later, to to be able to pick up on that threat. Then if it's detected in the environment, they will respond to it and then will recover. So it's that circle there as well, that is ongoing. So it's very relevant here in security operations as well. So for SecOps Zero Trust architecture, this is how security operations feeds into that zero trust piece. So it is actually a thing. You might be surprised to be like, well, security operations, that's operational, not architectural. Why does this matter? But in fact, it does, because there are certain things that you need to build into your architecture to be able to allow security operations to work well. So the first one and the main one is probably the centralized log collection. It's really important that all of our logs, because logs are how we monitor, logs have to be all together in a central place. It used to be that lots of applications and platforms would have their own logs and their own log stores, but this is really difficult to get an idea of what's happening across the entire organization if you don't have your logs together. So yeah, in terms of these best practices, for a start, log sources have to be integrated. One of my colleagues has an amazing phrase, which is collection is not detection. So even if you've got an application or an infrastructure piece that's generating logs, but you're not sending the logs anywhere, you're not sending them to a central place, you can't detect on it and we can't understand what's happening. The next bit, I'm talking about this more in capabilities. One of the other best practices is to select the right SIEM. Now, I say SIEM, which is Security Information and Event Management. In the US and North America, they tend to say SIM. It's all the same thing. It's all the same number of letters. So you choose how you say it. In terms of that scalability and redundancy, you probably know that since cloud, we've had this huge explosion of telemetry, what we call telemetry. So that can be logs, it can be other signals coming from different parts of an environment. And telemetry is noisy and it is intense. So we have to make sure that we've got enough architecture to actually accommodate the log sources and actually store all the logs that you need. But equally, we don't want to store too many logs because that storage will cost a lot in cloud. So there's an activity that has to happen there around how long do we need to store our logs for? In order to keep them for our security operations, but not too long that they sort of become redundant and we're just paying for them when we don't use them. And that calculation of what's right is going to change for every single every single organization is going to have a different take on what that will be. It's also worth mentioning there that there are jurisdictions and laws in some industry sectors and in certain jurisdictions where you have to store logs for a certain period of time. And so, of course, if that's the case, if you're beholden to that legislation, you will have to take that into account as well when you're making your decisions on that. Next up is securely transport logs. This isn't a massive problem anymore, but it is worth mentioning that logs need to be transported in a secure manner, because if not, they can be manipulated, they can be intercepted, which can allow attackers to hide their tracks or actually send the logs somewhere else. And potentially there might be some data exfiltration. In general, if you're using modern services, logs will be transported securely by default, but it is obviously worth checking that. And if you're building your own application, creating its own logs, then you do need to make sure that you're making sure things communicate securely. Though, as I said, you should be doing that anyway for everything. So, yeah. There is something called normalization. Now, normalization is a funny word. I think it's a funny word, but what it means is when you're getting logs from lots of different devices and lots of different places and lots of different vendors, the logs aren't all going to come out in the same format. And that can be a problem when you're trying to run detections against them, because you can't write a rule to look at lots of sources when they're not normalized and in a standard format. So normalization is the process of making logs into a standardized format, which makes detecting and running detections against them easier. And it means we get that full picture across the board, which is important. And then I kind of really talked about this already in the scalability and redundancy bit, because I tend to get ahead of myself. But of course, we have to consider the storage and retention period for logs. As I said, that's going to depend on the individual business, and also they might be beholden to some laws about that. Okay. So, in addition to centralized log collection, there are some best practices for security operations in IT environments, just generally like how we run it. So, of course, it sounds obvious, but worth calling out is continuous monitoring. Like, security operations is not a one-time thing. We have to be doing it again and again and again, because threats change all the time, environments change all the time, and so it's a continuous thing. There's also threat intelligence, which we've talked about before. So threat intelligence is understanding new threats. Maybe it could be bad IP addresses. It could be particular patterns of behavior. And we need to load into our security operations, and there's different ways to do it, new threat intelligence and fresh threat intelligence, so you can respond effectively. Another thing is user training. Now, I'm sure anybody who works in at least an office job will have done some kind of security awareness training, which of course is often phishing. I mean, I know we occasionally do it in Microsoft as well. I've done it at previous jobs where you'll be sent a phishing email and you need to not click on the link. That user training is really important, because it doesn't matter how well you do your technology, people are often still the weakest link, and someone clicking on the wrong thing in there, it's clicking on the wrong link, it can be game over. So, that's a difficult thing to deal with. It's also difficult because you can overtrain people as well on phishing, and people can start to get bored and not pay attention. So it's a very delicate balance to be able to get that right. But it is something that needs to be done with your security operations, because I'm sure if you've done this sort of training, you'll know that that if you do click on a link that you shouldn't click on and you think it's bad, you need to report it to your security operations team so they can investigate, just to make sure nothing's been compromised. Again, we have to do that. We are also taught to do that in Microsoft as well. We have a reporting line if you're concerned about anything security-wise. If you've clicked on a link, yes, but there's, of course, other things as well. Now, this is an interesting one, an incident response plan. That's something that every business organization should have. An incident response plan, obviously you can have incident response plans for all kinds of things in an organization, but this is specifically a security one. And you might be surprised to know that there's so many businesses out there. I would say the majority of businesses out there do not have a security incident response plan, or they do, but they've never tested it. We often say that running through an incident response plan kind of is a fake thing. We can call it a desktop, like a table read, and you read through it and everyone knows what they're supposed to do. The reason you should do this is because when it happens, if it happens, security incidents are chaotic. Depending on the exact nature of it, there's usually a lot of people worried, a lot of people trying to get things done. You might have media inquiries. Obviously, people are trying to get things up and running. And having a well-rehearsed incident response plan that you've gone through ahead of time can really help lessen the load of what is a bad situation and make sure step by step everything is gone through and nothing is missed. So then we've got security automation. So a lot of security operations, unfortunately, is very repetitive. So you do the same thing again and again and again and again. That is the nature just of monitoring in general. So where we can, we look to automate things and using automation and orchestration. And more recently, we're starting to get AI to help us, but that's kind of in its infancy, but I'm sure it will expand greatly, and that will help streamline some of these repetitive tasks that need to be done. And then finally, of course, SecOps should be working with IT operations to make sure everything is backed up and that the recovery plan, if you need to recover from a backup, everyone's tested and happy with it, because particularly for ransomware, where effectively your computer is all encrypted up and you need a key. The only way to do that without paying the ransom is to have good quality backups that have been done recently. And if you have those, then you can restore to a previous backup without having to pay the ransomware person. Sadly, the fact is that a lot of folks don't have good, solid backup plans, and the ransomware people take advantage of this. It's also worth calling out as well that because ransomware folks know that the backups are the way they can recover, organizations can recover without being paid, is that we are seeing some types of malware specifically go and look for backup type files, to encrypt them as well, to force people to pay. So it's also important, as a side note, that any backup should be very well protected and be separate to the rest of your environment for that reason. Okay, so let's look at the capabilities and the kind of tools we can use in security operations. The first one, which I already mentioned, is a SIEM tool, or a SIEM. Now, if there's one security operations tool you have, this would be it, a SIEM. So SIEM is essentially a tool that will aggregate and correlate all these logs that you've sent to a central place, and then it will run what we call detections or rules against it. So these detections and rules are looking for certain patterns of behavior in logs or certain things. So, for example, if you see somebody fail to log in 10 times and then they log in successfully after that, that could be indicative of a password spray attempt where someone tries a password semi-frequently, but not too frequently enough to get locked out. But it also could just be somebody who has forgotten their password and then remembers it. So there's different things that you need to run. And not all of them. And it's also worth pointing out that security operations isn't like a security operations aren't 100%. So it doesn't matter. It doesn't matter. Nothing's 100%. So we will get false positives. And so it's important to be constantly tuning things and be aware that not every single alert that's raised is going to be a real incident. But part of the job of a security operations person is to tune those alerts. If you're getting a lot of false positives, then they need to be maybe tuning the alert thresholds differently or writing the rule completely differently altogether. So really depends. But yeah, in terms of what a SIEM does, it collects logs, it will normalize them. So I already talked about normalization. It will then do correlation, and that's with correlating different events. So if you see a weird looking log on, and then you see that same account log into a machine or start using a machine that it doesn't usually use, you can start to build a chain of the different events and correlate them. And that's what a SIEM is really good for. Then, of course, if it does look like it's an incident, it will alert people. It will do notifications. Most SIEMs can do that in a variety of different ways. And then it may raise an incident that the security operations have to look at. It also does that automation and orchestration piece as well. Sometimes in the past you had to buy that separately to a SIEM, but most of them nowadays have it included. And then you can do automation to get rid of some of the repetitive tasks as well. And then they usually provide some kind of dashboard as well, so a visualization. I'm sure if when you think of security operations, you think of like a room that's got lots of screens and there's all these kind of charts and visualizations. That it depends. That I have been into places where that is a thing. It's not always the way security operations are done, but the SIEM tool is often the tool that's giving some good visualizations and dashboards that can go on the TV screens in the room, if you know the stereotype that I'm referring to. Okay, so next up is an XDR. This is a term that's been thrown around a lot recently. And essentially, XDR is kind of a security operations tool. It is of sorts anyway. It's an evolution of endpoint detection and response. So threat protection that we put on endpoints. I'm not going to call it antivirus because that's what it used to be in the past, but it has evolved far beyond that. So endpoint detection and response is EDR, and XDR is extended detection and response. So it's going beyond that endpoint thing and also bringing in more telemetry from different parts. So it's not, because I don't want to say it's a SIEM. They're very closely related, but it brings in some additional things. And the reason that XDR has been developed is so that an organization isn't really depending on just an EDR or a SIEM or individual security tools. It's trying to bring things together. As it says on the screen there, you have a number of different tools. So you've got it, like I said, it's integrating data from lots of different sources. That can be network, it can be cloud, it can be other things. And that just gives a broader context, because no security incident exists in isolation. So being able to get that additional context from other parts of the environment can help you understand, is this a real incident? And if it is, what's happening? It does analytics. Like I said, we call it detections or rules. The analytics looking at patterns of behavior. Is this unusual? Say, for example, Sarah has logged in to her machine in Australia, and then 5 minutes later, she's logged in the UK. That couldn't possibly be her, because you can't travel between those two countries in 5 minutes. Now, I could be using a VPN for some reason, maybe to watch Netflix, but it can be a legitimate sign that an account has been hijacked as well. As I said, it also will bring in threat intelligence, which is something we talked about was a good practice. And usually any good security tool, because it's on the bullet points here, any good security tool should be able to look across platforms, because very few organizations just have one platform. So even though everything I've talked about in Microsoft security land, and I know I said the point of the series is to not go much into tools, and we won't, but security tools need to be able to look at every platform. If you have a security tool that just looks at Azure, or just looks at GCP, or just looks at AWS, and you have some of those other environments, that's not really going to work. So the idea of the XDR type of technology is also to make sure that all platforms are covered. But as I said, that's something that all security tools should really do in order to be effective. There's other things that we can put in to security operations as well. I've already mentioned some of these, but we can put in, and it's happening more and more now, is machine learning and AI. We can also put in something called UEBA, which is user and entity behavior analytics. So this specifically focuses in on the behavior of a user account. Now, we talked about this a little bit in data security and insider risk, although it's not quite the same thing. So essentially what you're doing is looking, again, for patterns of behavior and things that are unusual. So I always give the example of, day to day, I just click on some documents, I do some things, I log into Azure, all of those things in my day to day at my job. However, if you look at, if I was suddenly logging into a load of folders I'd never looked at, and I was downloading loads and loads of files, that could be unusual. It could be that someone stole my account and is trying to steal data. Could be a number of things. So user and entity behavior analytics is a way of looking at typical patterns of behavior on an account and then flagging them if they start to do things they shouldn't do. You can also put threat intelligence feeds. You can pay for threat intelligence feeds, but there are also open source ones that give lists of something called IOCs, which is an indicator of compromise. So an indicator of compromise might be a file hash, it might be an IP address, it can be a number of things. And if you load that into your security operations and you see some of those IOCs, those indicators of compromise, it might suggest that this is actually a bigger threat than you thought. Not always, but can be. Of course, I talked about the orchestration and the automation piece already. Generally, that is built into security operations tooling now, though occasionally you might have to buy something separate. But that is to get rid of like the dross and the drudgery of doing the same things again and again and again. We can't always do it because we're always going to need people to look at things and interpret things, but it is something that helps. And then the last thing there is deception technologies. Now, deception technologies aren't used by every organization. Deception technologies are things called honeypots, where you basically make a very vulnerable looking application or server and you try and lure attackers into fiddling around with that particular honeypot. So the idea is, of course, calling it a honeypot, you're luring the bees to the specific honey or the flies or whatever. And the reason this is useful is that if you do have attackers in your environment, it can distract them. But it also, if they trigger certain things on the honeypot, you'll get an alert for that, and then there's someone in your environment doing things they shouldn't. So that's what deception technologies are. Not everybody uses them because they do need to be maintained and you need to be able to support them, but it is something that some businesses use. Okay, I'm going to pause for a second and take a drink and take a breath and see if there are any questions so far before we move on to application security. And I'm definitely looking at the right tab today, so. Okay, so let's move on. So application security. So that's often abbreviated as AppSec. And so this is specifically the process of how we secure applications. Now, applications have a lot of code. They can be written in lots of different ways, which means there is a lot of potential for security vulnerabilities. So we're trying to, and application security is about identifying them, fixing them, but ideally by doing secure software development lifecycle is that actually we avoid them being done in the first place. Application security is a very common target. It's where we see a lot of breaches. Of course, usually the applications are handling the data that we said in previous episodes, ultimately people want to get hold of. So application security is really important to get right, but it's also hard to get right. The principles are quite simple at a high level, but the implementation of them is hard. And it's also important to remember that I'm not sure if there's anyone joining us from the developer community, that it is a hard thing to do as a developer, to do all the security right and meet all your other goals. It is a challenge, which is often why we find issues. Okay, so here are some sort of principles of application security, some of the things that we look at. So first of all, we talk about secure by design. So this is what I was saying before, is that whilst we want to, if there are some security issues, we want to identify them. Ideally, we'd like just to not have any to begin with. And the way we do that is to have a proper secure by design principle and movement where security is thought about from the word go by everybody and by the developers, and they're thinking about it when they draw up the plans for the application and before they write the code, because it's much easier to write a secure application to begin with than to write something and then have to go back and fix it later. That's much worse. But some of the things we look at is input validation. So user input should be validated to make sure they conform to expected formats and that they're free of malicious code or data. The same thing for output. Well, for output should be encoded in the proper way because that will prevent vulnerabilities like cross-site scripting. Authentication and authorization. This is the identity piece, but the application should be talking to a proper identity store like Entra, not just talking to a random little store, or no authentication at all sometimes, in order to restrict who can access the application. Of course, we've got data protection. Now, we've already talked about data security, but within the application, it should be handling things in a secure way. It should be, when it's sending things in or out, they should be encrypted in TLS or SSL, TLS or similar, and an up-to-date version of TLS as well, not an old one, and things like that. Then other things that have and can be manipulated by attackers are session management. So, user sessions should be protected from hijacking and unauthorized access. Secure dependencies. Of course, this is supply chain security. Of course, there are a lot of dependencies around there's we need to make sure that because 90% of software is like reused in the patches and the packages, so when you're bringing those in, you need to make sure they're secure, because if the dependency you're using isn't secure, then you've already made your application secure. It's a very difficult thing to do, the supply chain piece, but it is something you should be looking at, and there are tools to help. Of course, error handling and logging, that has been known as an attack vector in the past. When you build an application, when it handles errors, does it just blurt out everything, or does it put everything in the error message? Does it just shut down and fail open or fail closed? Because if an application is shutting down, we'd want it to fail closed rather than fail open. Because of course, if it fails open and all the security controls have gone when it crashes, potentially we could extract things. And then, of course, as with everything, we need to test what we've done. So we need to check that it's actually secure and we've tested it properly. And all of this is under, or at least this secure by design is also known as the Secure Software Development Lifecycle, or the SDLC. And the idea with that is that we integrate security practices into every phase of software development. Cool. So let's look at some of the tooling. There's a lot of types of tools here. So I'm going to give you a list. There's about 13 of them, and I'll give you some examples as well. Some of them are paid for tools, some of them are open source, but let's have a little look at those. So first of all, these are some of the tools and the capabilities. So first up is static application testing, or SAST. SAST is looking at source code. It's looking, so you basically give it some code that you've written, and then it can verify whether it looks like you have vulnerabilities in there. So some examples of this are Fortify, Checkmarks, and Veracode. They are all tools that will check your code. Then we have the kind of sibling of that tool, which is DAST, Dynamic Application Security Testing. This is actually looking at an application that's running to identify vulnerabilities. And it does that rather than just by looking at the code and how you've written it. It will actually send requests and analyze the responses. So the Zap, Burp Suite, and Qualys are some examples of that. So that's like actually whilst the application is running, which is why we call it dynamic. Then we have interactive application security testing, or IAST. So that's kind of SAST and DAST. So it's looking at code. It's also doing the inputs. So it's kind of SAS and DAST put together. So there's contrast security and HCL that do that. And then there's also RASP. Many ASPs here. So that's application self-protection. So this is when the application is running and doing its thing. It will also look at how the application is running, and it will look at patterns to see if the application is starting to do things. Is it making calls that it never normally makes? Things like that. So looking at how the application runs and looking at if it starts to deviate from that, and that's RASP protection. I think I've definitely already mentioned this in networking, but it's worth putting in here as well, which is the Web Application Firewall, or WAF. So Web Application Firewall is working at the application layer, which is layer 7 in the OSI model, and it's looking at that web traffic and filtering it, looking for malicious inputs, etc. So there's many different WAFs out there. There's many. We have one at Microsoft. All the cloud providers do. But certainly, please never, ever, ever put an application facing the internet without a web application firewall, it's really important that the application has that protection. Then moving on a little bit, we have dependency scanning. Now, this is similar to vulnerability scanning that we talked about in infrastructure, but it's looking at dependencies. So it's basically looking at the third-party libraries that you use in your code and the components and seeing if there are any dependencies that need updating or are vulnerable. Again, there's a couple of tools out there. OWASP do a dependency check, and also Sneak as well can do dependency scanning. And as I said, these are just examples. This isn't a comprehensive list. There are other tools out there as well. Now, the next one, we have already talked about this, which is penetration testing. So they will use a variety of tools to pen test. It really depends. Metasploit and Mmap are some well-known security tools that have been around a long time, but there are a huge number of tools that penetration testers might use in order to test the application and see if they can actually exploit it. And then we've got general security scanning and analysis. Now, I have talked about this in infrastructure, but we can also do it across. We can do it across the application as well. So, yeah, lots of scanning there. I mentioned as well in infrastructure about container security tools, because containerized applications are slightly different in their structure. Traditional security tools can't necessarily scan a container and understand what's there. So there are some specific container specific ones out there like Docker and Aqua Security. They often do a number of things within the container. They will often have runtime, image, and sometimes some analytics as well, all running within the container. And then, of course, there's the education piece as well. Secure development training is really important for devs because we need to upskill people, because people are always the weakest link. So, of course, there are secure development training courses, for a huge number of courses out there, either online or in person, where developers can learn just good coding best practices. And then there are testing frameworks out there specifically for applications, OWASP, AMAS, OWASP OWTF, and for AppSec. They're frameworks as well that sort of tell you how to test as well and give you a step-by-step guide. And then similar to SAST, we have secure code review tools. That's looking at security vulnerabilities and coding best practices, like have you put cross-site scripting in? Are you sanitizing your input? There's a number of tools out there that you can do that with. And then throwing it in here, because it's such a huge part of applications nowadays, is secure APIs and microservices. So all applications are using microservices and APIs to some extent, or they'll be broken up into microservices. And of course, those components need to talk to each other and communicate in a secure way. And so there are tools out there that will help you with the authentication, authorization, and the data protection of moving things and communicating with APIs and other microservices. So again, there's Apogee, API Gateway, Istio. Again, there's a number of different tools out there that can do all of these things. So you need to go do your own research. And it's worth saying that you won't use all of these tools all the time either. It really will depend on the application, how much time you have, what it's doing, where it sits. But this is sort of, an idea of all the tools that are available to you to be able to do that testing. And with that, that is everything I had to tell you about today in terms of application security testing. It's a big topic, and security operations can also potentially be a big topic. But as you know, this is kind of an overview. I have got the right tab open, so I'm going to leave this open to see if there are any additional questions from anyone. And because this is the last session, if you have a question about anything else you'd like to ask related to the series, I mean, please put it in the chat. That's fine. Very, very happy to answer that. And yeah, I will wait a couple of seconds. I'm going to have a drink. And if not, I will wrap up and give you some final learning resources as well. You folks are all very quiet. Well, seeing as this is the last session, I guess what I would like to do is thank you all for your attention. Whether you've watched this on, if you've caught up on it later, or if you've joined me live, I very much appreciate it. I hope that you have found this interesting. If you want to continue learning, we have going into our official Microsoft Learn paths, which you can access on the links that we're putting in the chat. Also, ultimately, you might want to look at doing the SC900 exam, which is our Microsoft Security Fundamentals, if you're looking for a qualification out of this. This should give you a good grounding, but there is more material on Microsoft Learn. Of course, there is so much more I could tell you about security, so much more in depth, but this was supposed to be an introduction for beginners. I hope you found it interesting and useful. Please go keep learning about security. We need all the people we can get. It's a very rapidly evolving field. So even if you're new now, the knowledge that we gain is often out of date quite quickly. So please don't let that be a barrier to you wanting to get into this field. Hopefully you found this interesting and useful. And thank you very much. And we'll see if enough people liked it, maybe we'll do another one, maybe with some not fundamentals. We'll go into some intermediate stuff. But there is so much material that's very free for you to use out there. So my last piece of advice I'd like to leave you with is keep learning, but particularly if you're early in career or a student or wanting to switch careers, please don't spend lots of your own money on expensive training courses, because there is so much material out there that you can get for free or extremely cheap. And I would definitely counsel you to go and use that stuff first. And with that, I guess we'll wrap up. Thanks very much. I think this feedback stuff, please, if you enjoyed it, if you have feedback, whether it's good or bad, it really helps us improve. So do let us know when you get all the surveys. So yeah, thank you very much, everyone. Whenever you're watching this, wherever you're watching this, have a lovely day. And I'm sure I will see you all again on another series.